We'll just go over whichever ones you guys want to see. So which of those did we want to see adding to? 2. Okay. 4. Any others? Okay. So starting with number 2, solve the equation algebraically. So we had to first distribute. You could have done this in your calculator or by hand by making this into a fraction and multiplying across, so negative 15 over 6. Okay. That's fine. And then you could simplify that, divide both by 3. You get something like this. You could combine like terms on the right side, so we have 1/2 x minus 7 equals 11 minus 5 over 2x. And then you had a choice as to what you wanted to move. Let's say I got rid of this by adding. And got rid of the 7 also by adding. If I were to go ahead and combine those, that would be 6 over 2, which would give me 3x equals 18. So, I think I looked at this one. And then divide both sides by 3. So the x equals 6. Okay. Remember that while you're practicing, you could be double checking that in the calculator in Desmos to see those answers. Questions on that one? Number 4. This was like a 2-part. You had to solve it for x, but then solve it for k. If I think about it. So if I went ahead and distributed negative 8x minus 2 equals 1/2 kx minus 2. Sorry. So what I was thinking was get all the x's to the same side. But I think that's going to be more complex than I wanted. We'll try that first. And then get x out of it. So this part was more complex because we haven't talked about this. But we're going to like undistribute this. Usually when you distribute, you multiply it in, but we want to take that x out so that it's outside of parentheses. But then if I divide, that wouldn't give me the answer I'm looking for. Oh. Sorry. I think how I did this was because this has to be infinitely many solutions, we know both sides have to be the same. So that means this part, the negative 2, is already the same, and this would have to be equal to negative 8. So I set it equal to that. That's how I got that. I was just missing that step. And then I could solve this for k by multiplying both sides by 2. Sorry if that was confusing. Because then if I put negative 16 back in for k, this would give me negative 8, and then there would be the same on both sides. So, Arif, I told you wrong. My apologies. Questions on them? All right. We are switching gears today. So we've talked a lot this week and last week, just this week, I don't remember, about solving equations. We're still solving equations, but different types. So everyone look at your notes. Notice that this learning target says A2 and all the other ones have said A1. This is one of the extensions that regular Algebra 1 won't be talking about. So we are going to solve absolute value equations. In order to solve this, we first have to make sure that the absolute value expression is isolated. Today. What does that word mean, isolated? Alone. By itself. And then we're going to set the inside equal to both a positive and negative version of whatever it equals. We'll talk about that here in a second. And then we're going to solve both equations. And then we're going to write our answer as a solution set. So previously when we were doing domain and range, oh gosh. Awesome. Okay. Let me fix that first, because it's going to keep doing that in here now. Okay. I lost my train of thought. As we were doing solution set, we were talking about set builder notation, and now we're going to be doing interval notation, more with inequalities when we get there, but the solution set is kind of part of that. So when we get our answers, it's going to look like this. So to solve this, make sure the absolute value expression is isolated. So everything outside of the absolute value bars is away. In number 1, that's already the case. Then we're going to set the inside, so just the x, equal to both a positive, whatever it equals, so 2, and a negative. Because if we think about absolute value, that measures distance, and distance can't be negative. But I can go forwards 5 and backwards 5 and still have traveled the same distance. So absolute value is measuring distance. And then if I had something to solve, I would do that, but in this case there was nothing. So then those are my answers, and I would write that as a solution set. Least to greatest. If they happen to be the same number, instead of writing 2 separate numbers, you could write it like this. With a plus minus, the symbol is plus or minus 2. So you can write it either way. Questions on that so far? Okay. Number 2 is going to be similar, so we're going to move on to number 3. So, same process. Isolate the absolute value bars, it's already isolated. Set the inside, drop the absolute value bars as you're doing this, equal to both a positive and negative 40. Solve both by doing what? How would we get z by itself? Divide by 5. So that z equals a positive 8 and a negative 8. So you won't always get the same thing, but these happen to have the same thing. So again, you can write it as z equals, curly brackets, negative 8 plus 8, or you can write it as z equals plus or minus 8. Maddie?
Just wanted to make sure that if we did it in the curly brackets, it would be negative 8, 8, because you said it was least to greatest, right?
Unless you're writing it like this. Other questions before we move on to 5? Okay. So for number 5, same process. There's nothing to isolate, so we can go ahead and drop the absolute value bars, set that equal to a positive 8 and a negative 8. Notice that we're not changing the inside, but we're only changing the outside. And then how would I solve this? So both, yeah. So we have D equals 7 and D equals negative 9. So least to greatest, negative 9, 7. I could not use the plus or minus here because they're not the same number. Questions on that one? We'll do number 7, and then if you guys have any other questions on this page, and then we'll move on to the back. Same process is already isolated, so go ahead and drop your absolute value bar, set it equal to a positive 34 and a negative 34. How would I solve that? Subtract 2, sorry. To both equations, so we have 4n equals 32, and 4n equals negative 36. Divide both by 4. What are the two solutions? Negative 9 and positive 8. You were close. You have any questions on how we got that? Are there any others on this side that we want to see you go over and have questions about? Go on to the next, on to the back. So now we start to see where there are things outside of the absolute value bars. So we're going to isolate the absolute value bars. So you would treat whatever's inside the absolute value bars like the x you're trying to solve for, or the variable you're trying to solve for. So don't do anything inside or change anything. Deal with everything that's outside first. So get rid of the 2 by subtracting. Leave this in absolute value bars until you've gotten to the very last part, until it's isolated. I'm going to lock this page. So that the absolute value of C equals 10. And then it's just like what we did before. Drop the absolute value, set it equal to the positive and negative. From here, you could really go straight into, well, I know it's going to be positive 10 and negative 10, so I'm just going to put plus or minus 10. Questions on that one? Let's try number 11. How would I start solving that one? Divide both sides by 6, yes? So that the absolute value equals 4, you have to do that part first, rewrite it in absolute value, and then you can drop your stuff. Because if you put this as plus or minus 4, the absolute value can't equal a negative, so that would not be true. Let's do 12. What would be our first step? Keep everything inside the absolute value bars. And then once it's isolated, then we can drop them, set that equal to a positive and negative 7. And then we can solve what was on the inside by adding everything by 3. I'm sorry, subtracting. So that z equals what? 4 and negative 10. So in order, negative 10 and then 4, yes. Have any questions so far? Look at 13, 14, 15, and 16. Which of those would we like to see you go over, have questions about? Maddie? 13. Yeah. Any others?
16.
Okay. And really, if you could do 16, you could do 14 and 15 as well. So let's do those. So for 13, I gotta get rid of the 6 first by doing what? Multiplying on both sides. And then from there, what's our next step? Can I add 4 as is? I will be adding 4, but not yet. Drop the absolute value and what else? Also make it negative. So if you don't do the second part, you are missing half of your answer. So make sure you also make it negative. Because absolute value equals both a positive and negative. That's why we've been making it negative the whole time. Yes. So add 4. We have 2w equals negative 14 and 2w equals 22. Divide both by 2. What is w? Negative 7 and positive 11. Okay. A common mistake that I saw previously in previous years is that we would solve one and then at the end just make that a negative. That is not the same thing as making it negative at the beginning and solving for it. So make sure you're keeping those two straight. Make it negative at the beginning and then solve for it. Okay. Any questions on 13? Okay, let's do 16. What do we think would be our first step in 16? So if I were to divide by 3 halves, I would have to do that to this and this and this. So we could do that. But in this case, you would get whole numbers, but you might want to avoid dividing by fractions. What else could we do? Alex, say that again. So, okay, that would be similar. Instead of dividing, multiply each piece by 2/3. But again, you may not want to deal with all those fractions. There's something else, Axel. So that would be similar. And we wouldn't want to change it to a mixed fraction, Maddie.
Could we add 24?
Start there. get rid of this. Because if you start dealing with the fraction first, you're going to end up with fractions everywhere, and then it'll get really complicated. So now, we could divide, but I want you to get in the habit of taking it and flipping it and multiplying by the reciprocal instead. Would that be the same thing as dividing the fraction? Yes, but you don't want to have a fraction with another fraction, and then another fraction where you're dividing, and then all these fractions, and then you get confused. So if you multiply by the reciprocal, these fractions cancel, these 3's cancel, just leaving 2. Now we can drop the absolute value bars and do what? Okay. And? When you say add the negatives, at the beginning. Mm-hmm. So I'll write that over here. For our minus 4 equals negative 2, so we can also add that 4. And then what's that last step? Divide by 4. So in this case, we're going to end up with fractions. Sometimes that happens. What would those two fractions be in simplest form? You can simplify it algebraically in your head or simplify it in the calculator using your alpha y equals. What would those two fractions be? So we want them as improper fractions or just fractions. We don't want mixed numbers, Laura.
It would be 1/2 or
1 half is right. Oops. But the other one is not. It should be 3 over 2. Because this would, I could divide both of these by 2. This, I could divide both of these by 2. So 1/2 and 3/2. And if you get fractions and you're not sure which one is bigger, well, in this case, they both end up, the denominators are both 2. So 3 is bigger than 1. That's how you could reset that. But you could also just divide it, see the decimals to see which one is bigger. Questions on 16? Okay. So now we're going to move on to these special cases. And then I'm going to show you how you can check yourself in Desmos. And then you guys are going to have time to practice and do retake work. So for this, if I get something that equals a negative, an absolute value bar equals a negative, I can't solve it. You won't be able to solve it. So this would be no solution. Because the absolute value measures distance, I need to be able to isolate and set it equal to the equation to a positive and negative. And all the other examples we've done, if we had a negative on the other side, it eventually became a positive, and we were able to solve for it. Don't assume just because you see a negative that it automatically means no solution, because it could change. But if you get a negative after you've isolated, you can't do anything else. So like in this case, it looks like a normal problem. If I divide both sides by -3, I get that negative, I can no longer solve for this. So this would then be no solution. And I'll show you what that would look like as well. So isolated absolute value bar expressions cannot equal a negative. But that also goes back to the distance thing, because distance can't be negative. So isolated absolute value expressions can't equal a negative. If you were checking yourself, let's say you wanted to check these answers, you could put the 1/2 back in and it should equal, and the 3/2 and it should also equal. And that should tell you they both work. Now, if one works and the other doesn't, something's off there. You may have to go back and fix that. The absolute value bars, you can find them 2 ways. I'm going to get a poster that says this. But one, everyone do this. Alpha window. It's at the top. So yours may not look like this, but it should say ABS. So alpha window will give you the ABS. Or you can hit second, 0, and it's right there. So everything is in the catalog, the blue above 0. Everything can be found there if you're not sure where it is on the calculator. So either second window or alpha 0, and you will find it either way. I'm going to put number 16 in so you see what that looks like. To Desmos. Putting in the whole thing. The absolute value bars on Desmos are right here with the absolute value bar of A. Or you can type in the letters A, B, S, and it will also do the same thing. Just remember to change your variables to X, because it doesn't like other ones. So when you are checking yourself, it will give you 2 lines. You won't be able to click on them, but if you were to zoom in, you could see what those 2 are, where they fall on. If you got something that would equal a negative, you won't see anything. And that'll tell you it's no solution. You won't be able to do anything. So you can get 0 as an answer, but that would only be 1 solution. You could get 2 solutions, or you can get no solution. This one does not have an infinitely many. Okay, questions on that? I think in the Dust Math there was one thing I wanted to show you before you guys practice that. Let me double check really quickly. I may have been thinking about something else. Okay, yeah, no, you guys are fine. So, I want you working on the absolute value, equations, delta math. That one is due next week. If you haven't finished the 3 that are due today, multi-step equations, real-world problems, and multi-step equations with variables on both sides, work on those. Once you are done working on at least the absolute value equations, the others, if you haven't finished them, then you can come see me to finish test work on retake work. But do at least the absolute value equations first, and the discussion.